3. Statistical applications in environmental sciences. A x1, y1. B x2, y2. C x3, y3. Module 21. Applications of determinants. Objectives. 1. To familiarize the students with Kramer's rule for solving system of linear equations. 2. To find the area of triangle using determinants. 3. To derive the condition for 3 points to be collinear. 4. To derive the equation of a line passing through given points. Introduction to applications of determinants. Determinants have many applications in various fields. Determinants are used to check singular and non-singular matrices, and if non-singular, then it is used to find the inverse of matrix. Using determinants, linear system of equations can be solved. Using determinants, one can examine whether given system of linear equations have unique solution. So determinants have various applications. Determinants also play important role in the field of environmental sciences. Some of important applications of determinants will be discussed in this module. Area of triangle. Let triangle has vertices x1, y1, x2, y2, and x3, y3 as follows. Then area of triangle is given by plus or minus 1. 2. x1, y1, 1, x2, y2, 1, x3, y3, 1, where sign is chosen to give positive area as area of triangle cannot be negative. Proof. Let us consider in triangle ABC, having vertices a x1, y1, b x2, y2, and c x3, y3 such that yi greater than 0 for I equals 1, 2, 3. Also assume that x1 is less than or equal to x3 is less than or equal to x2 and x3, y3 lie above the line joining the 4. Statistical applications in environmental sciences. Points x1, y2, and x2, y2 as in figure 1. B x2, y2. C x3, y3. A x1, y1. Y. D x1, 0 e x3, 0 f x2, 0 x. Figure 1. Consider the trapezoids ADEC, CEFB and ADFB in figure 1. Then area of triangle ABC is given by area of trapezoid ADEC plus area of trapezoid CEFB, area of trapezoid ADFB, 1 the area of a trapezoid PQRS in figure 2, where PQ equals B1, RS equals B2 and H is height altitude is given by the formula 1. 2HB1 plus B2. Figure 2. So in figure 1, area of trapezoid ADEC equals 1. 2 y1 plus y3 x3 minus x1. Similarly, area of trapezoid ADFB equals 1. 2 y1 plus y2 x2 minus x1. Area of trapezoid CEFB equals 1. 2 y3 plus y2 x2 minus x3. Using 1, then area of triangle ABC is given by equals 1. 2 y1 plus y3 x3 minus x1 plus 1. 2 y3 plus y2 x2 minus x3 minus 1. 2 y1 plus y2 x2 minus x1 equals 1. 2 x1 y2 plus x2 y3 plus x3 y1 minus x1 y3 minus x2 y1 minus x3 y2 equals 1. 2. x1 y1 1 x2 y2 1 x3 y3 1. Pipe dot. If do not consider the assumptions. 5. Statistical applications in environmental sciences. yi greater than 0 for I equals 1, 2, 3. Also x1 is less than or equal to x3 is less than or equal to x2 and x3, y3 lie above the line joining the points x1, y2 and x2, y2 then we may obtain negative value of area. Then we should avoid the negative sign and choose the positive sign for area of triangle obtained. Solution. Using determinants, area of triangle ABC is given by equals 1. 2. Minus 1 1 1 1 2 1 2 2 1. Equals 1. 2 minus 1 2 minus 2 minus 1 1 minus 2 plus 2 1 minus 2 equals 1. 2 0 plus 1 minus 2 equals minus 1. 2. As we know, area of triangle cannot be negative, so just consider the positive value of determinant, i.e. drop the negative sign. So area of triangle ABC is 1. 2. Example. Find value of k if area of triangle with vertices 1, 3, 0, 0 and k, 0 is 3 square units. Solution. Area of triangle with vertices 1, 3, 0, 0 and k, 0 is 3 square units, so 1. 2. 131001k01 equals plus or minus 3. Rightwards double arrow. 131001k01 equals plus or minus 6. Rightwards double arrow 1, 0 minus 0 minus 3, 0 minus k plus 1, 0 minus 0 equals plus or minus 6. Rightwards double arrow 3k equals plus or minus 6. Rightwards double arrow k equals plus or minus 2. Condition for 3 points to be collinear. Let 3 points be a x1, y1 b x2, y2 and c x3, y3. Now these points lie on a line if and only if area of triangle ABC equals 0 if and only if 1. 2. x1 y1 1 x2 y2 1 x3 y3 1 equals 0. 6. Statistical applications in environmental sciences. If and only if x1 y1 1 x2 y2 1 x3 y3 1 equals 0. Example. Show that the 3 points 8, 0 2, 2 and minus 1, 3 are collinear. Solution. Evaluate the determinant. Pipe. 8012. We have pipe. 801. Pipe. equals 8 2 times 1 to 3 times 1 minus 0 2 times 1 minus 1 times minus 1 plus 1 3 times 2 equals 8 2 times 1 to 3 times 1 minus 0 2 times 1 minus 1 times minus 1 plus 1 3 times 2 times minus 1 equals 0. Hence given points are collinear. Example, show that the line joining the points minus 3, 1 and 3, minus 1 passes through origin. Solution, if line joining the points minus 3, 1 and 3, minus 1 passes through origin, then points minus 3, 1, 3, minus 1, and 0, 0 must be collinear. So let us check whether these points are collinear. Evaluate the determinant. Pipe. Pipe. So line joining the points minus 3, 1 and 3, minus 1 passes through origin. 7. Statistical applications in environment. x1 y1 1 x2 y2 1 x3 y3 1 equals 0. Equation of a line. We know 3 points x1, y1 x2, y2 and x3, y3 are collinear if and only if x1 y1 1 x2 y2 1 x3 y3 1 equals 0. Now, let we have to find a line passing through the points x1, y1 x2, y2. Then let x, y be variable lie on the line joining the points x1, y1 and x2, y2. So then points x, y x1, y1 and x2, y2 must be collinear. So equation of line joining the points x1, y1 and x2, y2 is given by x y1 x1 y1 1 x2 y2 1 equals 0. Example, find the equation of line which passes through the points 2, 2 and minus 1, 3. Solution, using the application of determinants, equation of line is given by type x y1 2 2 1 minus 1 3 1 equals 0, where x, y are variables. Expand the determinant on left-hand side by cofactors of first row, we have x2 1. 3 1 minus y2 1. Minus 1 1 plus 1 2 2. Minus 1 3 equals 0. X minus 1 minus y 3 plus 1 8 equals 0. X plus 3y equals 8. So equation of line passing through the points 2, 2 and minus 1, 3 is x plus 3y equals 8. Example, find the equation of line which passes through the points minus 1, 3 and origin. Solution, so we have to find the equation which passes through point minus 1, 3 and 0, 0 using the application of determinants, equation of line is given by type x y1 minus 1 3 1 0 0 1 equals 0, where x, y are variables. Expand the determinant on left-hand side by cofactors of first row, we have x3 1. 01 minus y minus 1 1. 01 plus 1 minus 1 3. 8. Statistical applications in environmental sciences. x3 minus y minus 1 plus 1 0 equals 0. 3x plus y equals 0. So equation of line passing through the point minus 1, 3 and origin is 3x plus y equals 0. Solutions of system of linear equations. System of linear equations. A system of n simultaneous linear equations in n unknowns x1, x2. xn is a 11x1 plus a 12x2 plus a 1nxn equals b1. A 21x1 plus a 22x2 plus a 2nxn equals b2. an1x1 plus an2x2 plus a nnxn equals bn. Where ij for 1 is less than or equal to I, j is less than or equal to n and bi for 1 is less than or equal to I is less than or equal to n are constants. This system of equations can be written in matrix form as opening square bracket a 11 a 12 a 21 a 22 a 1n a 2n vertical ellipsis an1 vertical ellipsis a nn closing square bracket opening square bracket x1 x2 vertical ellipsis x equals b1 b2 vertical ellipsis closing a 1n vertical b1 b2 vertical ellipsis closing square bracket dot. Homogeneous and non-homogeneous system of equations. A system of equations x equals b is called a homogeneous system if b equals O, 0 matrix i.e. b equals 0 0 vertical ellipsis 0. Otherwise it is called non-homogeneous system of equations. Solutions of system of equations. A set of values of the variables x1, x2, xn satisfying all the equations simultaneously is called a solution of the system of equations. 9. Statistical applications in environmental sciences. If a system has one or more solutions, then it is said to be consistent system of equations. If system has no solution, then it is said to be inconsistent system of equations. Methods for solving system x equals b. First we will discuss to solve a non-homogeneous system of simultaneous linear equations by Kramer's rule, named after the Swiss mathematician Gabriel Kramer. Kramer's rule for non-homogeneous system. The solution of the system of linear equations 11x1 plus a 12x2 plus a 13x3 equals b1. A 21x1 plus a 22x2 plus a 23x3 equals b2. A 31x1 plus a 32x2 plus a 33x3 equals b3 is given by x equals d1 d, y equals d2 D, Z equals D3D. Where D equals 11, a 12, a 13, a 30, D1, B. Conditions for consistency. For a system of three simultaneous linear equations in three unknowns. I. If D does not equal 0, then the given system of equations is consistent and has a unique solution given by x equals D1. D, y equals D2. D, z equals D3. D. E. If D equals 0, and D1 equals D2 equals D3 equals 0, then the given system of equations may or may not be consistent. However, if it is consistent, then it has infinitely many solutions. E. If D equals 0, and at least one determinant D1, D2, D3 is non-zero, then the given system of equations is inconsistent. However, if it is consistent, then it has infinitely many solutions. Algorithm for Cramer's rule for non-homogeneous system of linear equations. Step I. Obtain D, D1, D2, D3, where 10. Statistical applications in environmental sciences. In statistics, data have a vital role, and it is essential to have a clear plan or strategy while the collection and analysis of the data. The strategy that is used to take care of this motive is known as statistical design, that includes plans starting from the objective till the conclusion. In practical life, one is interested to make an inference from the experiments, as conducting experiments will help you to understand or give suggestions for improving the system, whether conducted in the lab or in open fields. For example, experiments are conducted in the lab in a controlled environment, and some experiments are conducted in the open and uncontrolled environment like agriculture field. The theory and methods that are used to take care of experiments are termed as experimental design. It is considered as a collection of techniques and methods that help the experimenter while conducting an experiment in terms of how to minimize cost, how to choose units and which model is more appropriate for the given objective, how to analyze the data and draw conclusions. In general, our main interest is to understand the system or process in detail during its operational phase and try to see the cause and effect relationship. For that, we either change the input variables or conduct the same experiment in different situation. This will lead to make statements or theories about the system. The main objective of these experiments is to determine that these theories or statements are statistical significant or not. Generally, experiments are considered as a criteria for testing or series of repeating the same technique or method to see the changes that can be observed in the output values due to change in the input variables. So our main interest is to find out those factors or variables that are responsible for this significant change in the output responses, as well as developing a model for the response variable with the significant input factors. After that, this model can be used for making an improvement in the system, making a further decision and forecasting the future values of the system for a given input factors values. 5. Statistical applications in environmental sciences. In this module, we will discuss a brief about how to make a good plan, conduct an experiment, and how to analyze the data while framing a valid statement about the objective using inferential statistics and draw a valid conclusions from them. Experiments have a wide application in different areas like sciences, industry, etc. There are many situations where the scientific laws can be applied in an effective manner, that one can develop mathematics relationship between the factors and can check its significance further using statistical techniques by just understanding these scientific laws. In science and production, we have units available, and experiments help to understand how the process works. So it is important to choose an appropriate experimentation technique, because that will lead to conclusion about the system. As the conclusion be drawn as a stepwise procedure, first we have to select the units or factors that are of interest to us. After that, statistical methods are used for collecting the information, then analysis, and at last give the conclusions about the objective. In general, process is considered as a collection of different resources like input factors and output responses. In production sector, input factors are people, raw material, and other things that are essential at initial stage to start the process. On the other hand, output responses are those that one can receive at the final stage. It is possible that some of the input factors or variables' properties are controllable or assignable. Controllable means that variable properties can be modified as per the requirement, whereas some variables' properties are uncontrollable or non-assignable. The purpose of conducting experiment may include the following. A. To find out the most influential variable on the response variable. B. To see the impact of the influential variable on the response variable value. C. To check whether with a small change in the influential variable will lead to significant change in the response variable. D. To see how to minimize the effect of uncontrollable values on the response variable. Hence, we can observe that in experiment we have different factors, and the objective of the conducting experiment is to find out the influential factors on the response variable of the system. The whole process of conducting experiment and planning is termed as experimental strategy. So it may be possible that experiment can change the strategy with time or due to structural change. In most of 6. Statistical applications in environmental sciences. The area, it is considered that one should start with a simple strategy first and then move to complex one. In the next section, we will discuss about some applications of experimental design that will help to understand its importance. 3. Applications of experimental design. In general, we understand the process in a series of experiments, and we make assumptions about the process while collecting the data and come to conclusions after statistical analysis. Based on the conclusion, we establish new assumptions that will lead to new experiments and so on. Hence, the process of experimentation keeps on repeating itself with the passage of time. The use of experimental designing in the process will lead to I. An improvement in the process outcome. E. Reduce the variability among the response variable. E. Reduce the overall cost. IV. Reduce the time period for developing. Also, the experimentation will help to understand the comparison between the different alternatives available for the process in terms of raw material, machines, human resources, etc. The experimentation will also help to understand the relationship between the factors that will help to see the output variable's characteristics. For example, one can check the robustness of the product with the change in the environmental conditions or input variables in manufacturing industry. This will help the experimental to make a conclusion about the quality of the product before make it approachable to the end user. Experimentation will also help in determining the key parameters as well as in the formulation of the new products. Hence, the use of experimentation or experimental design will help in selecting the products that are easier to manufacture, reliable, optimized, minimum production cost, short development time and easy product design, due to the extensive applications of experimental designs. 7. Statistical applications in environmental sciences. In service industry, manufacturing sector, software development and market research, it is essential for all nowadays to have some knowledge of this topic. In the next section, we will discuss about the 3 basic principles of design of experiment. 4. Basic principles of design of experiment. Design of experiment is the procedure of planning about how to conduct an experiment, how and which method will be used to collect the data and after that analyzed it that would bring the conclusion for the objective. It is essential to use statistical methods to draw meaning conclusions from the data. It is more appropriate method to use when we have the possibility of experimental error exist in the data. Hence we have the 2 aspects of any experimental problem. First is how to design the experiment and second one is its statistical analysis for valid conclusions. These 2 aspects affects each other in an indirect manner. So to understand the relationship in more depth one has to understand the basic principle of design of experiment. These are A. Randomization. B. Replication. C. Local control or blocking. Some statisticians also consider the factorial principle as the 4th one, but in the literature the above 3 principles are considered without any ambiguity. We will explain the principles of design of experiment in detail as given below. A. Randomization. It is considered as the initial stage of implementing the statistical technique in the experimental design. Randomization means how we allocate the experimental material to the units and how to repeat the run of the experiment. Both of these things are done in a random manner. Hence this principle is essential for removing any biasness that may occur while the allocation of the material to the units or from the repetitions of the experiment, as statistical methods require the observations to be independently distributed. Basically here the observations generally means errors to be independently distributed. The purpose of the randomization is to remove the effect of extraneous factors that may exist. For example, there is difference in the quality of the product. There are many possibilities whether the 8. Statistical applications in environmental sciences. Difference occurs due to difference in the raw material or due to machine operators. If we assign the different raw materials to different operators randomly, then we can eliminate the effect of extraneous factors. Nowadays programming language are widely used to assist the experimenter in selecting and choosing experimental design. With the help of programming one can see the runs of experiment in random manner, and this is possible through random number generation technique. Sometimes it is difficult for the experimenter to assign the material to the units in a random manner due to some constraints like location problem, difference in experience level among the operators, etc. So it is not possible to do complete randomization in some situations because that would increase time and cost. In statistics, there are many methods available that can tackle this type of problems and will give you the optimized results. B. Replication. It means an independent repetition of run for each factor combination. For example, if we have 5 treatments type of seeds and 5 units of lands. If we want to test the productivity of the crop with the type of seeds, then we have to assign each seed to 1 unit in a random manner. Now we also have to repeat this process further so that each unit of land will get each variety of seeds at least 1 time. Hence the process of repeating the experiment more than 1 time to get better understanding of the system is called replication. Replication has further 2 important characteristics. First, it helps the experimenter in estimating the experimental error. This error will help in determining whether the variations in the observations are statistically different or not. Second, it helps in estimating the parameter of the model in a precise manner. For example, sample mean is used to estimate the population mean. Sometimes persons consider the term repeated measurement as a synonyms of replication, but both have different meanings. Repeated measurements term is basically used to refer to those cases where some operations are conducted repeated on the same units, but in replications we repeat the experiment such that each unit will get in contact with different factor on every run. Hence replications not only reflects the source of variability among the responses within runs but also reflects the variability between runs. C. Blocking. It is the 3rd principle of design of experiment that is basically used to enhance the precision that will help to compare the factors of interest are done. Basically blocking is used to 9. Statistical applications in environmental sciences. Remove the effect of extraneous factors. These factors may influence the response variables but not in direct manner. For example, in a field experiment of testing the quality of different variety of seeds, then it may be possible that we cannot differentiate between the yield of crop due to different seeds because the difference in the yield may occur due to difference in the fertility of the land, so we have to take account of this factor while comparing the different variety of seeds in terms of yield of the crop. Hence, generally block is considered as the set of relatively homogeneous units, like field that has same fertility can be considered as a block, another field that has fertility different from the previous one will be another block. It is also observed that there is less variability within the elements in a block than the variability between the blocks. In this section, we discussed about the 3 basic principles of design of experiment: randomization, replication and local control or blocking. In the next section, we will discuss about the guidelines or rules that one should follow while planning for the experimental design. 5. Steps for the construction of experimental design. Before the construction of experimental design, it is essential for the experimenter to have a clear idea about the objective in advance. What is our objective, how to collect the data and how to do analyses of this data. In this section, we will discuss about this in steps as given below. First, to recognize the problem. It is essential to first understand the problem and make a valid statement about the objective. It may seem a very simple task at first approach, but it is not. as it require a lot brainstorming sessions to develop a clear objective of the experiment. Sometime it is essential to take input from all the concerned specialized persons about the system like engineers, marketing, management, customer and operators. Hence for designing the experiment the collective efforts of the group is required. It is helpful if we prepare a list of questions and problems that are raised by the experimenter. The clear statement about the objective will help for better understanding of the system and the solution to the problem. 10. Statistical applications in environmental sciences. It is also essential to keep the overall objective in mind while performing an experiment. There are many reasons for conducting the experiments and each experiment will generate its own series of questions. Reasons for conducting an experiment are given as I. The main objective of conducting an experiment is to determine or find out the major factors that have the most influence on the response variable. The process of finding the factors that are important is called factor screening. E. After determining the factors that the next step is to determine the optimal stage or level that will give you the optimal values of the response. For example, while experimentation of the yield of the crop it is determined that quality of seeds, fertility of land and fertilizers used are the main factors. Then the next stage is to find the optimum combinations of all these to get the best results in terms of increased profit or minimized cost. E. Now after determining the levels the factors, the experimenter is trying to verify that the system operates in the same manner as previously or there are some changes in the structure of the system with time. IV. It may also happen that the experimenter trying to apply new resources to see their impact on the system. For example, in manufacturing, experiments are conducted with new resources that increase the quality as well as the reliability of the response. Experimentation of this type will increase the demand of the product and overall profit. B. The experimentation will also help to test the robustness of the response variable. Under what conditions the value of the response variable will deviate from the target value. B. As we have already determined the factors those are the most influential for the response variable. Now the next step is to select the response variable. The experimenter should be certain about the response variable that will give the useful information about the system under study. C. After identifying the factors, the next important task is to categorize these factors into design factors, factors that are constant and factors that can vary. The design factors are those factors that are selected for study in the experiment. Constant factors have no direct impact for the current experiment but they can affect the system in future. Varying factors are those factors that have property of inhomogeneous among them, for example, the experimental units or materials are not. 11. Statistical applications in environmental sciences. Completely homogeneous. By using the principle of randomization, one can reduce the effect of this type of variability on the response variable. There are many other factors that have major influence on the response variable. These factors are called nuisance factors. Nuisance factors are classified as controllable, assignable, and non-assignable, uncontrollable. Controllable nuisance factors are those whose factors levels are set by the experimenter. On the other hand, if the factors are uncontrollable but still measurable, then the procedure that is used for analysis is called analysis of covariance. D. If we are able to categorize our factors, then the next step is to choose the design according to the objective. It involves determination of the sample size as well as number of replicates, determination of whether to involve blocking or not in the design. There are many statistical software available that will help to fit the model on the data. Based on the information in terms of number of factors and their level, software will recommend a particular model. It is also possible that one can compare between models based on the coefficient of determination as well as to give some diagnostic information about the performance of the model. This will help the experimenter to determine the suitable model for the objective. One can start from the very simple model and add the factors, variables in the model based on the requirements of the objective and attain the optimal model. E. The most important phase of designing experiment is the running stage of the experiment. It is important that process should perform according to the plan. If the process is not working about to the plan, then it will bring serious consequences like wastage of material, time, human resources, etc. So it is suggested that one should perform some pilot study or runs before implementing the experiment on the large scale. These runs will help to know about the consistency about the experimental design. If it is not working properly, then there is a need to cross-check all the previous stage and again do pilot study. F. After running the experiment, the next step is to collect the data to apply statistical methods on them. There are many software available that will help to assist in analysis. Descriptive statistics play an important role in data analysis at initial stage, but most the studies require methods of inferential statistics like estimation of variable coefficient, hypothesis testing and confidence interval. Residual analysis and model adequacy checking are among the major analysis techniques. 12. Statistical applications in environmental sciences. G. After analysis the data using the appropriate statistical methods, the next stage is to provide an appropriate conclusions about the results. One can also test the validity of the conclusion by performing confirmation testing. Hence, as we have observed the importance of experimentation and steps how to implement it, one has to work very efficiently stating from the initial stage of determining the factors till the conclusion to meet out the objective. 6. Use of statistical techniques in experimentation. The basic purpose of the use of statistical techniques in experimentation is to increase the efficiency of these experiments and to provide a valid conclusions. The following points should be kept in mind by the experimenter while applying the statistical techniques. The most important thing that the experimenter should have a strong knowledge in their field, as this knowledge will help in determining the factors that are most influential for the response variable and also in the designing of the model. B. Second important thing that the experimenter should keep in mind that one should start with simple statistical techniques and keep the design as simple as simple. As for a simple and reasonable design, the analysis will be very simple and it is easy to provide its interpretations. C. There are situations when there is a strong need to interpret the statistical results according to practical situation. For example, if there is a statistical significant difference in the yield of crop by using two quality of seeds, then one should consider the significant difference in terms of other factors like cost of production new seed than the old one as well as the total benefit that one will receive while using the new one. If the total profit that one will earn is negligible, then however there is a significant difference in terms of statistics, but in practical case there is no difference. D. It is possible that to draw a valid conclusion about the system one has to repeat the experimentation many times, as each experiment collects some information so one can use this information to get the better results in further experiments. In this section, we discussed about the points that one should apply before applying any statistical analysis on any experimental design. 13. Statistical applications in environmental sciences. 7. Summary. In this module, we first provide a basic introduction about design of experiments. 3 basic principles, randomization, replication and local control are also discussed in depth. We also discuss the important steps that one should know before planning for the design of experiments. At the end, we also give some tips for applying the statistical techniques in experimentation. 2. Introduction. In general, the experimenter is interested to investigate whether the observed difference between the treatment means are non-significant, occur by chance, or whether there exists an actual difference between the treatment means, with the help of experimental design that enable to compare the effect of different treatments on the response variable's mean value. In many situations, it is possible that the effect of treatments on the mean of response variable to be interested is only due to the variability that occur from the extraneous factors that are not of interest. To take care of this situation, a proper experimental design is chosen to get an appropriate result. We already discussed about 3 principles, randomization, replication and blocking in the module, basic principles of design of experiments. These 3 principles will help the experimenter to concentrate on the objective response variable and the statistical analysis as well as the estimation of the treatment effects and how to take care of the extraneous, uncontrolled, and non-assignable factors while building a model. 4. Statistical applications in environmental sciences. Basically, the completely randomized design is used to split the total variability into 2 segments. It follows the method of separating the total variability into components that have different source of variability. These source of variability are then compared, and this comparison will help to test about the significance of the null hypothesis that there is no difference exist between the treatment mean. It is essential that one should have a clear idea about testing hypothesis and statistical terms involved in them. One can refer to the modules based on testing of hypothesis and some parametric tests. The topic of completely randomized design is very important as it has wide applications in all the areas. To make this module simple and understandable, we split this topic into 2 modules. In this module, we will discuss about the theoretical part of ANOVA, including assumptions of the model, decomposition of the total sum of square, estimation of the model parameter, and statistical analysis. In the next module, we will discuss in brief about checking for the assumptions of the model and the pairwise comparison of the treatments with various tests available in the literature. In the next section, the introduction to the basic model of ANOVA is given in detail. 3. Analysis of variance ANOVA. In this section we will discuss about the analysis of the variance ANOVA of single-factor experimental design problem. This single-factor design contains one type of factor that affect the result of the experimental design. This single-factor design is also known as completely randomized design, CRD. ANOVA is the abbreviation for the one-way analysis of variance. Suppose there are p treatments or different levels of a single factor. Our objective is to compare p treatments or different levels of a single factor. Observation are recorded with respect to each of p treatments, and all observations are treated as realization of random variables. The recorded observation can be shown in the following table. 5. Statistical applications in environmental sciences. Treatments levels. Observations totals averages. 1y11 y12. Dot. 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 YP. Y. Table 1. We can see that observation of response variables are represented in terms of Yij, where I equals 1, 2. P is used for treatment or different levels of a single factor, and J equals 1, 2. N represents the observation with respect to ith treatment. We can see that there are p treatments and n observations in each treatment. Hence the total number of observation or NP. Notations. I. Y11 to first observation with respect to first level of the single factor. E. Y1n, nth observation with respect to first level of the single factor. E. YPN, nth observation with respect to PTH level of the single factor. IV. Y1, total of the all observations with respect to first level of the single factor. Y. 6. Statistical applications in environmental sciences. Statistical model. We should have to build a model for the recorded single factor observations with different levels. The model is similar as to the one-way ANOVA statistical model. The model is Yij equals mu I plus epsilon ij, where I equals 1, 2, 3. P and J equals 1, 2. N. Ij to ijth observation in the design. Mu I, the mean of the ith level of the factor. Epsilon ij, the error random variable that has zero mean. Error term are independent random variables that follows n, 0, sigma 2. Under this model, the error term are uncorrelated with the treatment. So Yij are independent and it is distributed as n mu plus tau I, sigma 2. If we want to write another form, the original model is also called the means model as it involves the effect of different treatments or levels of single factor due to its mean value. Now after transforming the original model, the new model is known as effects model. Both models are linear statistical models and also both are very useful in the experimental design literature, but effects model is widely used because it seems to be appropriate to incorporate constant mean and treatment effects separate in the model. In the treatment effects models, we can see 2 types of effects. One effect is if treatments are chosen by the experimenter. In this situation, we are interested in to test about the treatment means and after applying the statistical analysis the conclusion about the significance of the hypothesis, that is whether. 7. Statistical applications in environmental sciences. Reject the null hypothesis and do not reject the null hypothesis will be applicable only for the treatments taken in the study. The result cannot be generalized to other treatments that were not considered. Hence this type of effect is known as fixed effects model. Second effect is when the treatment would be taken as a random sample from a large population of the treatments. The conclusion by the testing of the hypothesis may apply not only for this random sample but also to other random sample treatments of the population. This effect is known as random effect model. This model is also known as components of variance model because in this model treatment effects are random variable and we try to test about the variability of the treatment's effect and also try to estimate the variability among them. In the next section, we will consider about the analysis part of different effects of model in detail. 4. Analysis of the fixed effects model. In this section we will discuss analysis of variance for the fixed effect model. Our objective for this analysis is to compare the mean effect with respect to different levels of the single factor. Let yi be the average of the observations under the ith treatment. Similarly, the mathematical forms are given as statistical applications in environmental sciences. There are certain assumptions for the analysis of variance. These are I. The population must be from normal distribution. E. The population must have a common variance. E. The observations must be independent. One has to test these assumptions before applying the model on the data. To test the assumption of normality and independence of observations, one has to familiar with the methods available in the literature for this purpose. Now, we have to apply the following method for testing the equality of hypothesis of equality of treatment mean or to test whether the treatment effect are 0. 5. Separation of total variability into components. In this section, we will discuss about how we can split the total variability into components associated with different source of that variability. The total sum of square is defined as n p I n j equals 1 p I equals 9. Statistical 2 n Hence the total variation in the data can be segmented into sum of square that we derived by subtracting the total average from the treatment average plus the sum of square of difference of the observation from the treatment mean. The symbolic notation for the above expression is given as SST equals SS treatments plus SSE, where SS treatments is called the sum of squares between treatments and SSE is called the sum of square due to error term. There are n observations in total, thus SST has n-1 degree of freedom. There are p levels of the factor, so SS treatments has p-1 degree of freedom. So the remaining term that is error has n-p degree of freedom. 6. Estimation of the parameter. In this section, we will discuss about how to estimate the parameters of the model. The parameters are mu and tau I equals 1, 2. P are estimated by using the method of least square theory. The error term is EIJ is defined as EIJ equals YIJ minus mu minus tau I. We have already covered the topic of completely randomized design with complete derivation starting from the building of the model, defining the null and alternative hypothesis, method of least square to estimate the parameters of the model including the variance sigma 2 with the construction of a ANOVA table and how to derive the values for different sum of square in the module, completely randomized design. In this module, we will discuss about the adequacy of the assumptions as one can only apply any model on the data if the data satisfy some assumptions. We have already covered the topic of completely randomized design with complete derivation starting from the building of the model, defining the null and alternative hypothesis, method of least square to estimate the parameters of the model including the variance sigma 2 with the construction of a ANOVA table and how to derive the values for different sum of square in the module, completely randomized design. In this module, we will discuss about the adequacy of the assumptions as one can only apply any model on the data if the data satisfy some assumptions. So this module will consider the methods that are available in the literature to test these assumptions. There are many methods that are available in the literature. We will discuss some of the most important methods only. We will discuss about the 4. Statistical applications in environmental sciences. Confidence interval of the parameters as well as the comparison of two treatments when our null hypothesis is rejected. 3. Checking the adequacy of the model. In this section, we will discuss about the validity of the assumptions before applying the ANOVA. We have to check the assumption of normality of the error term. There are methods like histogram, dot plot, line chart, QQ plot, cumulative frequency PP plots and through test Kolmogorov-Smirnov KS test, with S test, Jark-Barra test, Shapiro-Wilkes test and D'Agostino test. One can determine the normality of the error term. Graphical representation will not be the exact method to check about the normality of the data if the values seem like normally distributed but they are not actually normal. Graphical methods are not very useful when the sample size is very small. Then the histogram of the data does not look normal but in reality it may follow normal distribution. Statistical tests give more actual probabilities about the normality of the data. In the testing of hypothesis we want to test about whether the data was drawn from the normal population or not. The hypotheses to test about the normality of the data are H0. The sample data are taken from the normal distribution or the sample data are not significantly different from the normal population. H1. The sample data are not from the normal distribution or the sample data are significantly different from the normal distribution. There is a difference in testing of this hypothesis than others where our main motive is to estimate about the difference in mean, median and variance of the data. In these types of hypothesis of differences, our interest in to reject the null hypothesis. If the probability value p-value of these events is coming out to be less than 5%, then we reject the null hypothesis. Here in the testing for the normality of the data, our main interest is to see our p-value to be greater than 5% so that we can accept our null hypothesis. So if probability value greater than 0.05, then it means that the data follow normal distribution, otherwise the data are significantly different from the normal distribution. Note, as the sample size increases, it is assumed by central limit theorem that data follow normal distribution on approximate basis. So for very large data sets, the testing for the normality of the data. 5. Statistical applications in environmental sciences become less important. Also, it is generally assumed that the data follow normal distribution when the sample size is more than 30. 3.1 with S-test for normality. This test is very simple test that require only the standard deviation in the range of the data. The test statistics is defined as Q equals R S, where Q is the test statistics, R is the range of the data and S is the standard deviation. Steps for applying this statistics. I first evaluate the standard deviation of the data as square root of the variance. Second, find the range of the data that is highest value of the data lowest value of the data lowest value of the data R equals HL. Evaluate the proportion Q equals R S. Now with S-test uses a critical value to test the hypothesis. If the calculated value of the test statistics falls within the critical value given in the table of with S-test, then we accept our null hypothesis and do not reject our null hypothesis. If the calculated value falls outside the range, then reject our null hypothesis. Sometime we are interested to find out the p-value of test statistics. Then if with S statistics IEQ greater than 0.05, then the data are not significantly different from normal distribution. 3.2 Jark-Barrett test. A test that has similarity with the goodness of fit test. Here sample data have been tested whether skewness and kurtosis of the data matched with the normal distribution. K3 equals N area summation. Y minus Y3. K4 equals. And J 6 plus K. Where YI is the ITH observations of the sample data, N is the sample size, S is the standard deviation, K3 is the skewness data and K4 is the kurtosis of the data. 6. Statistical applications in environmental sciences. The value of the Jark-Barrett test statistic is compared with the chi-2 distribution table with 2 degree of freedom. If the calculated value of J be greater than chi-2 distribution tabulated value with 2 degree of freedom at 5% level of significance, then it means that the data is significantly different from the normal distribution and our null hypothesis is rejected. On the other hand, if the J be less than chi-2 distribution tabulated value with 2 degree of freedom at 5% level of significance, then we do not reject the null hypothesis and the data are normally distributed. 3.3 D'Agostino test. This test is considered a very powerful test to detect the departure of the data from normality. It is based on the D statistics, which gives an upper and lower critical values. The test statistic is defined as D equals T square root N3 SST, where T equals N area summation I minus N plus 1. 2 YI. D is the test statistic, SST is the total sum of square of the observations and N is the sample size and I is the order or rank of observations YI. Step to evaluate the test statistic. I first ordered the data in ascending order or descending order. Calculate the value of T by taking the difference of the ITH observation rank with N plus 1. 2N. Multiply it with the YI and take summation. Calculate the total sum of square IE subtracting each observation from the mean value of the data and square it. Now take the sum of all IB. Now put all the values in the expression of D. Compare the D value with the D'Agostino normality test table. If the value of the calculated D is less than the tabulated value, then do not reject null hypothesis, i.e. the data are not significant different from normal distribution. On the other hand, if the value of the test 7. Statistical applications in environmental sciences. Statistic is greater than the tabulated value, then we reject the null hypothesis, i.e. the data are not from the normal distribution. 3.4 Kolmogorov-Smirnov test. Kolmogorov-Smirnov is another test for normality. It is also known as KS test in the literature. The test statistic is defined as Dn equals maxi f express y minus f obs y, where fy is the cumulative distribution function of the random variable y for the observations yi, I equals 1, 2. N. F obs y equals no of observation below y no of observation. If we order the observation y1 less than y2 less than yn, then f obs yi equals I. N. Hence first calculate the difference of observed cumulative distribution function from the observed distribution function and choose the maximum among them. This maximum value is the value of the test statistic. Now we have to compare the value of the test statistic with the tabulated value of KS table. If the value of the Dn is more than the tabulated value for given n, then reject the null hypothesis, otherwise do not reject the null hypothesis. Note: for large sample dataset, the critical value may not be available in the table. So there is a formula to approximate out the critical value at 5% level of significance. It is given as D 0.05 equals 1.36 square root n. Here n is the sample size. Now the next question is, which test we should use to test for normality? To answer this question, we discuss here the features of different tests. With S-test. 8. Statistical applications in environmental sciences. It is considered as the simplest test among all the tests. It also has some drawback that it is not available in statistical softwares like SPSS. JARC-BERA. This test statistic is basically used to test the normality through skewness and kurtosis, and it is very effective. D'Agostino. It is the most powerful among all the tests. Kolmogorov-Smirnov. This test is generally used in the practice, and this test is not sensitive to problems in the tails. This test is only give more appropriate results when the sample size is greater than 50. This test statistic is generally available in statistical software. Note, as we discussed about the validity of the assumptions and how to verify them, but if the data error terms are not from the normal distribution, then what is the problem? As we already discussed that our results are only valid if our data meet some assumptions. As errors are not follow normal distribution, then it may lead to serious consequences for the experimenter to make any statement about the problem. So it is essential for a person to cross-check about the normality of the data not just by graphical methods but also through the above tests. In the next section, we check the validity of the second assumption, that is equality of variance of the dataset. 4. Testing for the equality of the variance. The most widely tested statistic that is used to test about the equality of the variance is Bartlett's test. The null hypothesis is H0, sigma 1. 2 equals sigma 2. 2 equals 2 minus n area 2. 5. Testing the treatment means using least square methods. In this section, we will discuss about the testing of the treatment means. When we reject our null hypothesis of the ANOVA table for the testing of treatment means of more than two groups, the next step is to find out the pairs of the treatments that are not significantly different, or to establish the ordering among the treatment's means. So if there is any significant difference between the treatment means, we can take two pairs at a time to compare the treatment means between them to see which pairs are not statistically significant, so that we can put them in the same group, and which pairs are statistically significant, so that order them according to their mean values. The steps are given below. Let us suppose we have P equals 4 treatments. First, find the treatment mean and arrange them in ascending or descending order as Y3. 10. Statistical applications in environmental sciences. In the next step, we have to examine about the treatment mean through testing by taking two pairs at a time. We know that for the testing of means of two group with unknown variance, t-test is used under the assumption of equal variance. Our hypothesis are H0, mu2 equals mu1. H1, mu2 does not equal mu1. In the above hypotheses, we carries out two-sided test of the hypothesis. That means we are interested in to check whether our second treatment's mean is significantly greater than or less than first treatment's mean in both directions. It would be observed from step 1 that we already arrange the treatment's mean in ordering, so if you have an idea about the means of two treatment, then we can modify of hypotheses as follows. H0, mu2 equals mu1. H1, mu2 less than mu1. In this case, the test statistic is called one-sided test. In general, the test statistic for the two-sample problem when variance is unknown is defined as y1 minus y2 minus mu1 minus mu2 s square root 1. Introduction. This design is an extension over the CRD design, where the effective nuisance factor needs to be control. Nuisance factor is that factor which has an effect on the response variable in an indirect manner. It is possible that this nuisance factor cannot be determined and uncontrollable, but we just have the information about the existence of this factor. As we already discussed about the three principles of experimental design: randomization, replication, and local control. Here randomization is used to remove the effects that occur due to nuisance factor. It is also possible that we have some information about the nuisance factor and it can be controllable. In this situation, we have to introduce the concept of blocking or local control in our model. It is basically used to eliminate the effective nuisance factor while the testing of treatment means. Hence, due to involvement of the blocking term as well as randomization in the model, the design is named as randomized block design. While building the 4. Statistical applications in environmental sciences model for the observation, we want to keep the experimental error term to be small as possible, as we are more interested in removing the variability that arises due to the effective experimental error. Hence, the randomized block design helps the experimenter to take care of this variation. Suppose the experimental area is heterogeneous and we want to control the variability of the experimental material with respect to effective randomization in one direction. Randomized block design is used to control the variability of the experimental material that are divided in groups into homogeneous subgroup or strata or blocks perpendicular to the effect that arise in the experimental units. Hence, the main purpose for blocking is to provide same platform to the treatments, so that one can test the treatment mean in more appropriate manner, and the variation that appear in the treatment's values on the experimental units are not influenced by any external factor, rather they only arise from the variation in the features of the treatments. 3. Randomized block design. In randomized block design, treatment are randomly applied to the homogeneous units within each block and replicate over all the blocks. In this module, we discuss only about the model of the RBD. In literature, one can read about how to estimate the parameters of the models and what are the methods that are available in the literature for estimation. While estimation, it is also essential to take account of some conditions. In practical life, there are situations when data from some individual units are missing. To solve this type of problem, the missing plot techniques is used. One can refer to the literature for in-depth study of RBD. Nowadays, statistical softwares like SPSS and programming language like R, Python are used to do the analysis part of the experimental design like CRD, RBD and Latin square design etc. 3.1 Statistical analysis of the RBD. Suppose we have P treatments that are to be compared within Q blocks. The structure of the RBD will be shown as 5. Statistical applications in environmental sciences. Treatments block 1 block 2. Block Q1. 2. 3. 9. Statistic. Three point two Other aspects of randomized block design. There are situations when increment in the expected response variable by few units due to any treatment or due to any block, then how to take care of this increment in the model. In general theory, it is considered that in RBD the principle of additive theory is used. As we have already defined, the RBD model is the sum of mean effect, block effect, treatment effect and error term. Hence it is assumed that if treatment or block increase the value of the response variable in units, then that incremental value will be reflected in the total value, but this is not considered as a relevant situation in general. The reason behind this is that if change occurs due to any treatment or block in response variable, then there is a 10. Statistical applications in environmental sciences. Chance of interaction that occur between treatment and block. So there is a need to incorporate interaction term in the model, but it not recommended to use interaction term as it inflates the residual mean square that adversely influence the treatment mean comparison. To tackle this problem, we have to use another design like factorial designs. 3.3 Random treatment and block. The design that we discussed in the previous section consider both the treatments and block as a fixed factors. There are many situations where both the treatments and blocks are random. In most of the situations, blocks are considered to be a random quantity. It will be beneficial for the experimenter to check the validity of the experiment across the random sample of the blocks. 4. Latin square design. Latin square design is another design that utilizes the principle of blocking. It is possible that in the experimentation of the system we have more than one nuisance factors. If we have only two nuisance factors, then the design that consists of taking account of these factors is called Latin square design. The most important feature of Latin square design is that it is in square arrangement and usually denoted by the Latin letters. Hence the design is named after the Latin letters. The main purpose of Latin square design is to remove the variability that arises from two nuisance factors. In Latin square design we implement the principle of blocking in two directions. Hence rows and columns are generally considered as the two-way factors that restrict the implementation of randomization in the testing of treatment mean. In this we have P2 cells and treatments are represented in each cell with Latin letter, and each letter occurs one and only one time in each column and row. The statistical model for LSD effects model is given as Similarly, time series is a sequence of observations in specific order, but these observations are time dependent. Actual time series is realization of stochastic process. In different sectors like economics, commerce and environment, events happen over a period of time. For example, temperature of a day at different time interval and price of commodity in one month to other month, or it may be day or year. Production of crop varies over year. Production of an item in an industry increase or decrease depending on the demand of the product. Sale of goods depend upon the price as well as need of the product over the time, like in change of technology. Consumption of items increase with increase in earning over time, or decrease due to lack of money, like visit to hotels depends upon person's earning that varies over time. These examples show a series of data which are dependent on time. This measurement of variable at different time point is known as time interval in literature terms. Time interval may be hours, days, quarters, months and years. In modern literature, time series is also referred as both data and process. Hence time series has a great importance in business, economics and other areas. This is the main reason for the development of many statistics tools, especially for these areas exist in literature. Even a particular subject named as econometrics originate to cater the need of this topic. Econometrics is now among the most widely taught subject in the colleges and other institutions due to importance of happening of events over a period of time. 4. Statistical applications in environmental sciences. Definition. A time series is a set of statistical observations arranged in chronological order, by Morris Hamburg. A time series may be defined as a collection of reading belonging to different time periods, of some economic variables or composite of variables, by Yalun Cho. Time series is a chronological sequence of observations of quantitative variables that are recorded successively at regular and specified time interval. 3. Functional relationship. Time series is a sequence of observations with respect to study variable and time interval. It means there is a relationship between study variable and time interval. For example, suppose a researcher records temperature of a place on a particular day in any weather condition, then recorded observation would be different in different time interval like hours, days and months. There is a relationship between temperature and time interval. This relationship can be defined in a mathematical functional relationship. The functional relationship of time series can be described as yt equals ft, where yt is the value of variable under considered time t. According to this functional relationship, temperature of a place is a variable whose values are considered yt at time t, and t represents different time interval of equal length. 4. Classification of the time series. Time series can be classified in two types. First is according to dependency on time, and second is according to variable numeracy. Dependency on time can be further categorized into 1. Discrete time series. 2. Continuous time series. Variable numeracy has further two categories. 1. Univariate time series. 2. Multivariate time series. We will now discuss these classification in detail. 1. Discrete time series. A time series is discrete time series when variable dependency on time is of discrete form. A variable is said to be discrete if it takes only integer values like days, months, etc. For example, closing price of daily stock market. 5. Statistical applications in environmental sciences. 2. Continuous time series. A time series is continuous time series when variable depends on time is of continuous nature. A variable is said to be continuous if it takes values in continuous form like in second, minutes, etc. For example, hourly reading of temperature. 3. Univariate time series. A time series is univariate time series when there is only one type of study variable or one characteristics under consideration. For example, share price of one company. 4. Multivariate time series. A time series is multivariate time series when there is more than one type of study variable that is of interest in time series. For example, share price of one company, share price of other company. 5. Components of time series. Study variable take different values in a particular time series. This difference in value is not due to only one component like time but affected by more than one component or multiple components. These multiple components pull up and down the values of the characteristics under study. For example, the crop yield depends on weather condition, seed quality, land quality, fertilizer, etc. Here crop yield is study variable and weather condition, seed quality, land quality are other multiple components that are also responsible for the yield of the crop. Figure 1. These multiple components are classified into 4 categories, such as 1. Secular trend, long-term movement. 2. Seasonal variation, short-term movement. 3. Cyclic variation. 4. Random or irregular movements. 6. Statistical applications in environmental sciences. These 4 categories are known as components of time series. Now let's discuss components of time series one by one with examples. 1. Secular trend. Secular trend or generally trend is a long-term movement. In general, trend shows tendency of the time series data in long-term period. This tendency may be downward and upward. It should be kept in mind that this tendency of upward and downward movement should not remain same throughout the time span. It is also possible that it can be observed in different time section or time span. However, one can say that the overall tendency of the series seem like moving upward or downward, but in actual there are many factors that persist for a long period. Tendency depends on the effects of the factor. If effective factors on time series data is of increasing, then it shows upward tendency. If is on decreasing, then it shows downward tendency. Trend consists of long-term effects. Long-term cannot be defined exactly because in some cases 2-year time may be enough and for some cases it is not enough. For some cases 5 minutes is a very long period, for other cases it may not be appropriate. The term of long or short period of time depends on the nature or objective of the data. In some cases, a period of hours can be considered as very large, while in other cases even the period of years is not sufficient to be named as long time. For example, if data of agriculture production. Figure 2 of 24 months shows increment in the growth of the crop, then it is not considered as secular trend for 2 years. The count of bacterial population of a culture in every 5 minutes. If this tendency of increment persists for a week, then it is a secular trend. One important thing is that the values for short period, maybe 2 to 3 years in some cases, are mainly affected by cyclic variations. Hence the values are not able to reveal true trend. In order to solve this problem, one should consider the multiple cycle periods to see the impact of cyclic variations on the values. For some cases, due to nature of. 7. Statistical applications in environmental sciences. The data-like increment of bacterial population persists due to strong germicide in an hour, then reading in every 5 minutes or in seconds would lead to a general pattern that can be termed as a secular trend. This tendency of the data may be linear and nonlinear trend. It depends on the nature of the data. If the time series values are plotted on the graph with more concentration around a straight line, then trend pattern of time series values are said to be linear. On the other hand, if the time series values are not close to straight line, then it is called nonlinear trend. Like increase in the price of gold, crude oil in the international market is not constant and varies with different phases of time. Hence the trend of time series will help you to get a general idea about the pattern of the behavior of the data under consideration. This will help in forecasting and future planning of different sectors like business, weather and economy based on previous values. With the use of trend analysis, one can compare 2 or more time series over different time periods and draw important conclusions based on them. 2. Seasonal variation. Seasonal variation is a short-term movement in a time series. Short-term movement means observational data collects in less than 1 year of time period, i.e. data collected monthly, quarterly, weekly, daily, hourly, etc. If collected data are annual, then there is no seasonal variation. As the name suggests, seasonal variation means variation that occurred due to change in season and natural forces in any study variable. For example, prices, production and consumption of any commodities, sales and profit in any departmental store, etc. Some variations in data are due to natural forces like seasons. For example, sale of umbrella increases in rainy season, consumption of ice cream increases in summer, price of woolen increases in winter. Some variation are due to man-made conventions such as sale of jewelry and price of clothes go up due to marriage season and in festival like Diwali, Christmas, and Durga Puja. The following image shows sales of clothes changing in different seasons. Figure 3. 8. Statistical applications in environmental sciences. 3. Cyclic variation. Cyclic variation is a repeated pattern in a time period of a time series. This time period will be more than 1 year. The data of sale of ice cream for few years shows that the sale of ice cream is high in summer and low in winter. Therefore, this data shows some repeated pattern in time series data. This pattern is known as cyclic variation. Generally, cyclic variation shows in business cycle. Business cycle have 4 phases. Hence, this is referred as 4-phase cycle, such as prosperity, recession, depression, and recovery. Each phase in business cycle persists for a very long-term variation, approximately 5 to 7 years. On the other side, cyclic variation may be short-term and long-term movement that depend on time period, but time period must be greater than 1 year. Figure 4. 4. Irregular component. Irregular component is also known as random or residual component. Every time series must contain this fluctuation, and this fluctuation cannot be removed from the data. Irregular component can be found by removing all three components, so that irregular component is not affected by other three components of time series. Irregular component is beyond the control of human being and considered as unpredictable. This type of fluctuation may be seen due to effective factors like earthquake, wars, floods, famines, political unrest, revolution, epidemics, etc. Irregular variation or unpredictable due to its accidental variation. For example, rise in prices of LPG gas cylinder due to strike of workers, etc. 9. Statistical applications in environmental sciences. Figure 5. 6. Mathematical model of time series. In analysis of time series, there are types of problems like to identify the components and their effect on the data sets, to isolate, analyze, and measure them independently. In literature, there are some mathematical model to decompose the time series into its components. Additive model. Additive model of a time series can be expressed as YT equals TT plus ST plus CT plus RT, where YT is time series value at time t. TT is trend value at time t. ST is seasonality value at time t. CT is cyclic value at time t. RT is random or irregular value at time t. All four component of time series in additive model operate independently to each other. Thus, in additive model, there is no effect of one component to other component. Additive model can be used to measure one or more component by elimination, i.e. by subtraction. For example, time series decomposition of additive model with visualization is in the following image. 10. Statistical applications in environmental sciences. If all component of time series operate proportionally to the general level of the series, multiplicative model is appropriate. Multiplicative model can be expressed as YT equals TTX STX CTX RT, where YT is the value of time series at time t. TT, ST, CT, and RT is the value of trend, seasonal, cyclic, and irregular component respectively. Multiplicative decomposition of time series is same as the additive decomposition of logarithmic values of the original time series, that is. Figure 7. 11. Statistical applications in environment. For example, time series transform multiplicative to additive decomposition by using logarithmic with visualization as given in Figure 7. It means that when the observations are related with each other in proportionate manner, then by taking log of the observation we can convert the multiplicative model into additive model, as it is easier to detect the components in additive models than multiplicative model. By taking log of observations one can smooth the curve. In practical cases, it is most widely used concept to take log of observations to determine the model that fits in an appropriate manner on the observations. (12) Statistical applications in environmental sciences. Hence, from figures 6 to 8, one can understand the mathematical model of time series components. One can choose an appropriate model based on the relationship among components in the data values. Mixed model. Some time series data shows different type of models under different type of assumption. This different type of model is known as combination of additive and multiplicative model or mixed model of time series. Some types of different model are 7. Utility of time series. Utility of time series is given as 1. It helps in understanding past behavior of the time series. To understand the past behavior of any time series, to analyze variation between data sets over a period of time. 2. It helps in future prediction. By observing past behavior of time series data we may see how observation are varying. According to behavior of data one can use this information for forecasting. We know that time series depend on past data. For better prediction of values one require long period data. 3. It helps in understand current situation of the problem. The actual performance can be analyzed by taking difference between expected performance and cause of variation of the data. 4. It facilitates comparisons between different time series. 8. Requirements of time series. Time series have following requirements. 1. Data must consist of a homogeneous set of values. 2. The data should be available for sufficiently long period. 3. Time gap between various values must, as far as possible, be equal. 4. The gaps, if any, in data should be made up by interpolation. 13. Statistical applications in environmental sciences. 9. Application of time series. Time series analysis has wide application area. Most important area of time series analysis is economic and business. Some other application areas are weather forecasting, pattern recognition, earthquake prediction, mathematical science, and mathematical finance. Time series analysis is mostly used in forecasting or predication. 10. Summary. This module is an introduction to time series. Here we give a basic introduction of time series analysis and attempt to explain its meaning, concepts that help in understanding its vast application areas. Classification of time series like univariate, multivariate, discrete, and continuous are discussed and their differences analyzed from one another. After that, components of time series like secular trend, seasonal, cyclic, and irregular are discussed in detail with graphical understanding so that they are easy to learn and differentiate from one another. Mathematical model of time series like additive model, multiplicative model, and mixed models are shown with their mathematical formulation to know about the importance of time series and its applications. Utility, requirement of time series and its application are discussed for in-depth knowledge of this topic.